In this example, you are conducting a study to see if the probability of catching the flu this year is significantly less than 0.81. You use a significance level of alpha equals 0.1. So our null hypothesis here would be that p is equal to 0.1, and because we're testing whether or not we have evidence that it is significantly less than 0.81, our alternative hypothesis will be p is less than 0.81. We have a sample size of n equals 297 and 232 successes, meaning that out of that sample of 297 people, 232 of them caught the flu this year. Let's compute the test statistic for the sample, the p-value, and then interpret those in the context of this particular problem. So let's come over here to StatCrunch and go to the stat menu. This is a proportion hypothesis test, and we have one sample with a summary. All right, so our summary, we have number of observations is our sample size of 297. The number of successes is given to us as 232. Our null hypothesis is that p is equal to 0.81, and the alternative, we have to make sure we change this, is less than 0.81. Let's go ahead and compute. Okay, our test statistic is the z-stat right here, which is negative 1.2676. So if we round that to 3 decimal places, it would be negative 1.268. The p-value is 0.1025 to 4 decimal places, so let's include all of those, 0.1025. Okay, now let's just quickly, before we do any interpretation, go back over here to our standard normal curve. And so that's, of course, a mean of 0, a standard deviation of 1. What we would do here to visualize what's going on here is put in our z-value, our test statistic of negative 1.2676. Let's go there. And when we compute that, we get a probability value of 0.1024 when rounded, and taking into account that 7 in that 5th decimal point gives us this p-value. So basically this has to match. I mean, this is telling us basically that our particular sample is negative 1.2676 standard deviations below the mean of the sampling distribution, and that the probability or the area under the curve to the left of that number is 0.1024. So we have a relatively high likelihood of getting that kind of sample. And so here when we go to answer these questions, our probability value is greater than alpha because 0.1025 is larger than alpha equal 0.10. And then this allows us, does not allow us to reject the null. So our decision is that we fail to reject the null. We only reject the null when our p-value is less than our designated alpha value. So we fail to reject the null hypothesis here. And so our conclusion would be that we do not have enough sample evidence to support the claim of the alternative hypothesis that the probability of catching the flu is less than 0.81. Notice that there is another option here that says there is not sufficient evidence to warrant rejection of the claim that the probability of catching the flu is less than 0.81. If you read this carefully, this is basically saying that we don't have enough evidence to reject the alternative hypothesis. What we reject or fail to reject, however, is the null. So that's why we wouldn't choose this one here, and instead we choose this one, because this one says we don't have enough evidence to reject the null, therefore we don't have enough evidence to accept the alternative, which is the claim that the probability of catching the flu is less than 0.81.